process generated database table, and as I said earlier, we'll use the data element ORTID. And with this basic definition, so the defaults, like it is not a hierarchical object, time validity is not required, the key cannot be changed, and so let's keep this as a standard. We don't need to define the active area at the level of entity type because we have already defined this in the data model. Now let's click on the second tab. Let's go to the attribute and quickly let's define some generic attributes for the entity type location. So let's say a location will require an address attribute like city, and we know that in standard SAP we have a data element. So let's use the standard data elements. So quickly we'll create a few. So we know that this is the land one. We will then create another attribute, let's say name, and let's call this as AD name1. The other attribute could be a description, and let's call this as AD underscore remark, and let's define another attribute called street, and this street could be so AD street, and let's define another attribute which is called the postcode or the zip code, and we know that in standard SAP there is a data element called PST-CD1. So with this basic definition of as you see on the screen, this basic definition, we will then create so I think in the description, so the data element here, instead of, let's use the other one which is remark 1. So city 1, land 1, remark 1, name 1, street, and PCD. Now let's also define one of the fields as required entry. Let's say on the UIBB we need the name attribute as a mandatory attribute, and in standard ERP data dictionary we know that for the country there is a standard search help. So let's so the use of search help is not encouraged, but if it is part of the standard entity, then we may use it. So with this attribute definition, let's go to business object type and link this entity type with the BO type that we created earlier. So ZA AC01, and let's define this ZAC01. This is what let's verify, ZAC01, ZAC01, and we'll then check this. So it says data model is checked for inconsistencies, and so far there are no errors. So after this let's save this data model. The system will require a request, and let's pick up one of the requests which is already defined in the system, and then our structure for the data model gets saved. Now So this we created in the configuration workbench, and after save we can also go to we can see the same data model definition within the GUI application. So we have this added data model, and here also we see that MDG location with the given prefix package, the active area definition, and inside this we'll see uh, one entity 1 defined, and within entity 1 there are several attributes that we have defined. So, and below this we can also see the relationship of the BO type. So after we make sure that these entries are according to our need, we can then activate this data model. So activation of the data model uh, generally may take a couple of seconds or maybe a minute, and this activation basically leads to the creation of the MDG staging area. From this data model perspective, means the system will generate the required tables wherein we can store the data which is under the process of change request. So we see that the data model gets created, and as a subsequent step we may go to the data model specific structures. So here we see that the mapping structures or the data structures using the prefix and the default package, they are created by the system, and we can then save this structures. So this is generally one of the a follow-on step that we need to perform after the activation of the data model. So let's go to the data model and press this option to compare the data version with the active version. So we see that there is a consistent data model, and there are two versions. One is inactive, and after the activation of the data model we can also see the active version of the data model ZA. Now once this the basic definition of data model is defined and the activation happens, now let's look into this data model, and let's try to find out how it looks in the standard so uh, the list of generated tables, which is basically the staging area for this data model. And in order to view this we may go to the object navigator, and then we may run a standard program which is USMD data model, and then go to the transactions and then click on the test, and where we can enter our own data model. So now here we see that an entity type called location gets created, and there is a physical table within the staging area, and this physical table, the structure of the physical table aligns with the attributes. So these are now the fields that make up the table which is called location. And if we see the content, then obviously we don't expect any content at this point of time, but then we can see city, country, nodes, name, street, postcode, So these are the attributes that we define within the data model, and this gets highlighted here. Now also, you know, when we activate a data model, the system also creates a mapping structure or an abstract structure. It's called as a general model, and we can open this general model from the transaction general model browser, and within this model browser there is a standard naming convention for the various abstract structures. So general model basically it has three different versions. One is single object processing, there is also multiple object processing, and there is also hierarchy processing. So depending upon the context of our data model, the system will generate different general models. So in the context of our example, we may look into the single object, which is ZSP. This is followed by the identifier for the model, data model. So we call this as ZSP underscore ZA, and we display it. So this definition, so we'll see a node structure with the representation of our data model. So we call this as a abstract structure of our data model. So here we see the root object, we know that is called as location. This is our entity 1, and if our data model has various other objects like dependent objects, entity 4, then we may find the suitable representation in the general model for dependent objects as well. So the root object has a key structure, it has an attribute structure, and these structures are generally used for mapping with the various applications like building the web services, building the IDOC structures, key mapping, value mapping. So the system will require the data structures to map the different attributes. Also, this general model will be used as a source model for the user interface applications, which is our web info applications. So on the right hand side you will see there is an implementing class. This basically is like an abstract class. It's a high level class, which means any enhancements or modifications that we require, that we need, they can be done using by creating a new class and inheriting this class. So we can do the redefinition of the methods within this class, which helps us to further enhance our UI models. So we can have enhanced feeder classes, enhanced connector classes. So after this, when we go to UI model, we can have an additional set of properties that can be implemented using the suitable enhancement of the implementation classes.